So the next thing that I want to talk about before we practice half reactions some more, because we'll practice them a lot. The next thing that we're going to talk about is oxidation numbers. Oxidation numbers are, they're going to be defined in a few different ways depending on what science, what discipline you're thinking about. But in chemistry, we're going to define oxidation numbers as numbers that we use to keep track of electrons in a redox reaction. They're handy for tricky or complicated redox reactions where it's kind of hard to write a half reaction and figure out exactly what's being oxidized and what's being reduced. And just a way that we can kind of very quickly see the oxidation process and the reduction process. And so what I want you to learn how to do is assign oxidation numbers to atoms that are in a molecule. So here are the steps to assigning oxidation numbers. In a molecule, every single atom gets its own oxidation number. Every atom that is an atom individually or an ion or part of a molecule or part of a polyatomic ion, whatever, every atom has an oxidation number. And the oxidation number is not a constant. So the oxidation number for oxygen, it could be 0, it could be -1, it could be -2. It depends on the situation. So you have to be able to assign oxidation numbers to every atom given its situation. And what I'm going to do is give you 4 steps that you have to follow in order. You can't pick or choose which step to start with. You must start with step number 1. And the first step is that hydrogen atoms they always have an oxidation number of +1. So whether it's a hydrogen in a compound, hydrogen as part of some sort of polyatomic ion, whatever, it's always going to be +1. There are 2 exceptions. The H2 molecule, in the H2 molecule, hydrogen is 0. That looks like oxygen. I'm going to write the word 0, 0. And then also there is something called a hydride, H- ion. In the hydride ion, hydrogen is -1. A hydride ion is really uncommon, but you might see it in a compound like LiH, NaH, something along those lines. So this would be a hydrogen anion, pretty uncommon. So that's step number 1. Once you assign all of your hydrogens, then you move to step 2. Step 2 is about oxygens, and oxygens are always -2. There are some exceptions as well. The first exception, oxygen, O2, the molecule, in that molecule, the oxidation number of oxygen is 0. And then the other exception is the peroxide polyatomic ion, which is O2, 2-. In that situation, the oxidation number of oxygen is -1. And so you could see that in something like H2O2, that's the most common place that you would see the O2, 2- ion. So once you get all of your oxygens assigned, then you move on to step 3. Step 3, for a monatomic ion, that means an ion that is made of just one type of atom like K+ or Na+ or Li+ or N3-. A monatomic ion, its oxidation number is the same as its charge. So Cl-, its oxidation number is -1. Na+, its oxidation number is a +1. N3 minus, its oxidation number is a -3. It's just equal to its charge. And sometimes it's easy for us to see the oxidation number of these ions because they're just written individually all by themselves, like Cl minus or Na plus or N3 minus, but sometimes we might see an ionic compound like NaCl, and then we would have to remember the charges on those individual ions before we could assign their oxidation numbers. So we'll have to remember how we come up with the charges on the ions. So once we get through all of the monatomic ions, the last step, step number 4, the sum of all the oxidation numbers in a molecule or a polyatomic ion or a compound or whatever, the sum of all of the oxidation numbers is always equal to the overall charge. So let's look at a couple examples of this, like using the NaCl again. The overall charge on NaCl is 0. It's neutral overall. The overall charge is 0. The oxidation number for the sodium is +1. The oxidation number for the chlorine is -1. And when you add +1 and -1, you get a total of 0, which is equal to the charge. This rule 4 is going to be really helpful when we're dealing with things like SO4 2-, and we have to assign what's the oxidation number of each individual thing. We can say, well, the overall charge of this polyatomic ion is 2-. We know from rule number 2 that oxygen is always a -2. We have no idea what the oxidation number is on sulfur, but we do know that when we add all these up together, all the oxidation numbers together, they're going to total up to a -2 because they have to match, the sum has to match the overall charge. Well, so let's figure this out. We have 4 oxygen atoms in this molecule. Each one has an oxidation number of -2. So that's a total of -8 for all the oxygen's oxidation numbers added together. So what does sulfur have to be? -8 plus what equals -2? You guys are pretty good at math. So this helps us figure out the charge on an atom like sulfur if we don't have a rule to help us figure it out.